So here we have three things, right? We have a compound that is molecular, we have a compound that is ionic, and here we just have a molecule that's made of two identical atoms. So I think I just answered the question, right? This is the ionic one.
Mm-hmm.
But how would I know?
Metal and non-metal.
Exactly. Which told these people, some don't know what that is. They don't know what ionic is. And if you are those people, I think just go back. Just go away. Don't talk to me anymore. Okay. Stop asking me questions. Question 2. A student mixes HCl with HClO4 and then dilutes the mixture with distilled water, total volume of 500 ml. What's the concentration of the hydronium in the final solution? Okay, so shall we find the mole of the HCl before and the mole of the HClO4 before? This is before, right? Okay, so we're gonna get 0.25. Look, whenever they say mixing, that means you gotta find the mole before. You're gonna find the molarity after, right? So this times 100 ml divided by 1000, you get 0.025 mole. And the mole of the HClO4, you do the same thing. You multiply the molarity by the volume, divide by 1000, and you have, how much will that be? Will that be 0.10 probably?
Yes.
Yeah, 0.10. Now that's before, okay? How about after? Now, so the mole before was basically 0.025 and 0.10, and if you were to add them, you would get 0.125 mole, okay? Now, how about the after? You'll do the molarity of the hydronium afterwards. Just divide the moles by the combined volume, right? So now the whole volume is going to be 500, the whole thing. So divide by 0.500 to make it into liters, and you should be getting how much? Like double that?
So C. 0.
So it should be 0.250. Yeah, it should get double that. So it should be choice C. Okay. Question 3. Which of the following correctly compares the atomic radius of F to that of O and provides the best explanation? So first of all, are they in the same period or the same group?
Same period.
Same period. O is in group 16 and F is in group 17. And so by definition, if they're in the same period, as we go from left to right, the atomic number will increase. And so if they're in the same period, only focus on the atomic number, right? So F has more atomic number or more protons, which would lead to less size. So F has to be smaller. So it's not A and it's not B. F has to be smaller. Why? Because of having more protons. And the other way for seeing more protons is having a greater effective nuclear charge. So it's going to be choice C. Okay. Question 4. We got 2 steps here. They're asking about the catalyst. As we know, a catalyst should not be consumed in the reaction. That means one time it appears as a reactant in one step and it appears as a product in the subsequent step. So here Cl appears as a reactant in the first step and appears as a product in the second step. So it's going to be Cl, that's going to be our catalyst. So it's choice B. Okay. So here we have to identify the identities of ions X and Y. Now, as we can see, this is just a water molecule with the shaded part being the O, because O is larger. So you're going to have O, H, H. Okay, we'll just make it a bit bigger. OHH. O is partially negative, H is partially positive. So if the H is orienting toward the X and H is partially positive, X has to be
Partially negative.
actually just a negative ion. Okay, just a negative ion. And since the O is orienting toward the Y and O is partially negative, Y has to be a full positive. So Y is positive and X is negative. Okay, so Y is positive and X is negative. Okay, so it is going to be choice C. Good. Okay. Question 6. Which of the following is going to increase the amount of the NO2? And that means the reaction has to be shifting toward the product to increase amount of the NO2. So to shift toward the product, you must either remove some amount of the product or you have to add some reactants. And so the answer is going to be A. Because if you were to remove some CO from the system, the right side will decline. We have to go toward the right side to make up for the decline. So it's going to be A. Which element has a lower boiling point? Okay. So which element has a lower boiling point? So Ne or Xe? Okay, first of all, in the same group or the same period?
They're in the same group.
Okay, so this is Ne and this is Xe. So, okay. Which one is going to be having lower IMFs?
Any
Because why?
less electrons.
Less electrons and therefore less polarizable electron cloud. So Ne is going to be the one. And by the way, Ne and Xe only have London dispersion forces because they only are noble gases. They don't bound anything else. So we should just compare their LDFs by the number of the electrons. So it's going to be A. Based on the positions of the elements in the periodic table, which of the following groups contain compounds that are most likely to have similar chemical properties? Well, they must be all in the same group. So like Cl, Bri are all halogens that are in the same group. They're going to have similar chemical properties. And they all have the same first element, which is K. So it's going to be choice A. Okay. 9. Which of the following pairs of diagrams represents the change with the greatest positive value of delta S? Okay. So that means the most randomness, right? You get the most randomness. And the best way to get the most randomness is to go from solid to gas, which is going to be choice C. Okay. This is solid because they're packed up without any space between them. And this is gas because they're going to be all floating around and everywhere. All right? Good. So here we have a nice reaction between K2Cr2O7 and C2H5OH. And we get this weak acid CH3COH called acetic acid. Okay. The structural formulas of C2H5OH and CH3COH are given above. Okay. Which of the following gives the correct hybridization of the valence electrons of the C atom? So that's attached to the OH. So how many things do you see on the C?
4.
So that's going to be sp3. And how many things on the C? 3. sp2. Because look, some people count a double bond as 2 things. It's actually 1 thing. So there's going to be 1 thing, 2 things, 3 things. So from sp3 to sp2, it's going to be choice D. Good. How many moles of electrons are transferred when 3 moles of C2H5OH which is in the balanced equation, react with Cr2O7 according to the balanced equation. So we should basically just take one side and try to cancel out its charge. Which side do you think I should work with? The right side or the left side? Which one is easier to work with? The product side?
Product side.
Right? It only has one ionic compound or ionic species. So you should think, if I have 4 Cr3 plus, then how would I cancel that? You should have 12 electrons, right? Because 4 Cr3 plus has 12 pluses, so the best way to cancel it is to have 12 minuses.
So, can't we just multiply this one by 3?
Okay.
It says 3 moles, so multiply the whole equation by 3. Basically 4 times 3.
Yeah. Or you could look at the half reactions. How would 6 and 4 meet? They would meet at 12. So you must multiply the first one by 2 and the second one by 3. You end up with 12 electrons. So yeah, it's the same exact thing. You're right. Very good. 12. Very clear. Okay, which of the following? This is like a test for your eyesight, and is it just me or it's blurry?
No, it's perfectly fine.
Oh god, it's just me. Which of the following correctly identifies the value of E and predicts the sign of delta G for the reaction at 298 Kelvin? I think I passed the test of the reading test. Okay, so look. First of all, where is our cathode?
That one.
So how would we know? Look, how would we know? Because we're not told if it's galvanic or electrolytic, right? So how would we know? The way you do it is you look at C2H5OH, which is a reactant. So you must also have it as a reactant in the half reaction. So in which half reaction do we see C2H5OH? In the second half reaction, but it's a product. That means I actually have to flip my second half reaction to make C2H5OH into a reactant. And by flipping it, it's therefore going to be our anode. But the Cr2O7 negative 2 is a reactant in the first half reaction. It's reactant in my full reaction, so I don't flip it. If I don't flip it, that's it. It's the cathode. So now we do E cathode minus E anode for the E cell. So 1.33 minus negative 0.78. Now back in the old days, you gotta do this without a calculator. But that's back in the old days. 2.11 volts. If I can read this correctly, it's not C or it's not D.
It's A.
And yes, if the E cell is positive, delta G has to be negative. That's just the rule, Danny.
In FRQs, are we supposed to mention the
equation? Yes. So if it was an FRQ, you must say delta G is equal to negative NF E cell, and you gotta continue the work. Good. A student is given the task of making a calibration curve for COCl2 for use in a spectrophotometry experiment. The student pours a sample of COCl2 of known concentration into a cuvette. Okay, so right now we're dealing with the Beer's law because I see the cuvette. And you guys know the joke. If you're under 18, you cannot use Beer's law. Very funny. Now,
So I remember last year you gave us like this one weird example of like drinking piss.
Oh yeah. If you are in a laboratory and there's nothing.
Would you like to explain it again?
I mean,
To distill it.
it's recording, so maybe not. But it was just a test of your mental health. Would you drink it? Or would you distill it first? If you distill it, you don't die. And if you drink it, you would die because it's
Acidic.
gross, plus it's very salty. And so would you have the right mindset to actually distill it and get the pure water? And if you did, I would unlock you from that jail in the lab. Mm-hmm.
So you still remember it? That means you've used it before again.
I think I did.
Yeah.
Probably this year. Okay. The absorbance is too high. If the absorbance is too high, it's because we did not wear gloves. Now, if you want to make the absorbance less, so to fix the situation, so if the absorbance is too high, how would you make it less? You simply have to add some water.
Like distilled, right? Or how?
Dilute, we say. Distill is something else.
What is the difference?
So distill means you remove the water from a solution. You just keep the solid part. Dilute means just add water.
Oh, okay.
Yeah. So dilute. Okay. Good. The rate law for the reaction represented above is determined to be K(N2O), which of the following best explains why increasing the initial concentration of N2O increases the reaction rate. Well, does the rate constant change if you increase the concentration of something? No, the rate constant only changes if you change the temperature. So it's not going to be C. Do you guys know what effective collisions mean?
Stronger collision.
Not quite. Effective collisions means collisions at higher temperatures.
So
If you want, it's not B. No, effective collisions I'm saying. If they say effective collisions, they mean collisions at higher temperatures. Without telling you. Okay, so it's not B because we have a constant temperature, so it's not B. So if you increase the concentration of something, you just expect it to collide more. But be careful, please. Effective collisions means collisions at higher temperatures. Okay. Very good. So here we have zinc reacting with CuSO4. What do you think we're going to get? We're going to get zinc SO4 plus Cu. They set a brown solid at the bottom of the beaker. Okay. A brown solid at the bottom of the beaker. Tamam. Which of the following best represents the species that react? So look, zinc is a solid, Cu is a solid. They have to remain. So we're going to have zinc solid giving us Cu solid. The equation is already fully balanced, so it's not A. But the CuSO4 must be broken up. And the same goes for the ZnSO4. Because both of which are aqueous, both of which are not solids. You must break them up. So you're going to get Cu 2 plus SO4 2 minus zinc 2 plus SO4 2 minus. And of course now you're going to cancel the SO4s. And you're going to have just a zinc solid with a Cu ion giving you a zinc ion with a Cu solid. So the answer is going to be choice C. Good. Okay, so which one here has more speed? O2 or X? O2, right? So O2 here has more speed.
Right.
So X has less speed. But they're at the same temperature of 300 Kelvin. So how would something have more speed? It is lighter. It has less molar mass. So what's the molar mass of O2? 32. That means the molar mass of X has to be more than 32. And CH4 is 16, He is 4, N2 is 28. It has to be A. Because Br, I think, is 79.9 times 2. That's much heavier than 32. Okay. So, you want to have increasing solubility, which basically means that you want to have, so look, the most soluble one is going to be the one with the biggest
KSP.
KSP. So which one here is the biggest KSP?
COOH.
The CO. So look, biggest KSP means more solubility. So you have to have COH2 on the right side. So it's not B and it's not C.
Oh, right.
And you have to have the least KSP on the leftmost.
So it's D.
Exactly. Very good. Okay. So here we have a cation and also an anion, right? Is that ionic or molecular?
Huh?
Ionic.
Nine.
And when the layers slide past each other, that's called brittleness.
Breaking up.
Okay? If it was metallic, you would say malleability. But if it's ionic, you would say brittleness.
Isn't there also brittleness in metallic or no?
There is not. Okay? Good. All right. Which of the following is the most likely identity of the element? So look, guys, we'll just do the math, right? When the atomic mass is 69, it is at 60%. Atomic mass of 71, it's at 40%. 69 times 0.6 plus 71 times 0.4. Let's see how much we get. 69.8. So which element is that?
GA.
Ga.
Gallium.
Gallium. Exactly. Good. Okay. You want to have the greatest mass to undergo the indicated change. You know what that means? You must find the mass 4 different times. And you would hope your choice is up there in the beginning, at least. Ready? So look, if we're just melting, you would just do 10,000 is equal the mass of the melting times the heat of the fusion, which is 330. Who has a calculator? Do the math and let us know how much you get. 30.3. That's A. B. Boiling the water, so the same procedure, 10,000 is equal to mass times the heat of the vaporization. I'm sure that the mass is going to be less than 30, right? What do you guys think? Because the 540 is bigger than 330. Don't do the math, just move on. Increasing temperature. So now we're going to say 10,000 is equal to MC delta T. M times C times delta T, which is 100. So 10,000 is equal to M times 240. Okay. That should be more than 30, right? So what's that over 240? That should be 41.7. Okay. How about D? So 10,000 MC delta T. M times C times delta T of 200. M is equal 10,000 over, I think, 80.
125.
That's the biggest mass, right? So it's D. Okay. The volume of the solution became twice as big. So, what does that mean in terms of molarity?
Twice as big? The what?
The volume. Molarity will go down, right?
Yeah.
So look, let's just assume here the volume is 1.
Isn't it B?
Based on what?
I just looked at it.
You're right, it is B. Because the mole, we have 4 moles because we have 4 dots over 1. You get 4 molar, which is the most molarity basically. Okay? Very good. Okay, whenever they give you Kp and they give you partial pressures or concentrations, they're asking you to find the Q, essentially, and you must compare them. Okay?
What?
Whenever they give you Kp, and they also give you concentrations or pressures in the question, they're asking you to find Q, basically. Let's find Q. Let's write the equation out. So H2O plus CO giving you CO2 with H2. ICE, because we have K. We have H2O at 0.30, 0.10, 1.5, 10. Which of the following occurs as the system approaches equilibrium at 500? So look, just find the Q and we're going to find out. So you're going to do products over the reactants. How much will that be? That should be 500 if I'm not mistaken. And you should always put the K on the left and the Q on the right when you compare. 500 is bigger than 136. The reaction is pointing to the left. So you're going to have to go left, basically. And if we go left, we're going to be increasing water. We're going to be increasing CO.
Why do we do ice?
Actually, there was no need. No, there was no need. We just did the I part of the ice.
I was looking for the change the whole time.
Don't look. Very good. No need for the ice table. Get it together.
Why is the ICC?
That's my favorite. Okay. Okay, so we're looking for the equivalence point, right? You know what that means? We have to use MA VA is equal to MB VB.
Yeah.
The molarity of the acid, which is the HClO, is 0.200. The V of the acid is 25 ml. The good thing about the MAVA is equal to MBVB is that you can keep the ml as ml. No need to convert. That's the only good thing. The rest suck. What's the molarity of the base?
Your
Don't
point?
have it. Gotta find it using
And we gotta find it what?
the above equation. The above numbers.
So here we have two missings, right? The molarity of the base and the volume of the base. Okay, now we have two missings, right? So right now it's our job to know what the molarity of the base is by using the first row. So I'm going to say molarity of the acid times the volume of the acid, molarity of the base times the volume of the base. Let's find the molarity of the base. Who has a calculator here? That would be really good so we can move it.
Wait, can you go up a little bit?
Yeah. Thank you. So 0.104. You're going to plug that in here. You're going to find the volume of the base. So volume of the base is equal to 0.104, 0.200 times 25.0. 48.0 ml. The answer is going to be choice C. Very good. Okay. So here we are talking about 3.9 gram of K. Okay. And we're looking at how much energy is released by the reaction. So we are given the delta H of the reaction. We're supposed to be using this equation. Delta H reaction is equal negative Q over N Rxn. Right now we're looking for the Q, right?
That was not written in the equation sheet, is it?
No, it's not.
It's not. So negative 393 is equal to negative Q over N reaction. Now what exactly is N reaction? It's the mole of your limiting reactant divided by that coefficient of 2. So you must
0.05 or 25.
divide by 2. So Q is equal to, you're going to cross multiply them and you get the answer.
How do you get the N reaction?
You find the mole of your limiting reactant and divide by the coefficient, which is a 2. How much do we get?
90.65.
19.65.
Yeah.
So the answer is going to be D.
But how can we know that it's absorbed or released?
Okay, so
Or in this case,
look,
shouldn't it be B?
look, whatever. So look, basically delta H is negative, right?
Yeah.
If it's negative, that means what?
Thermic.
Exothermic. So it has to be released.
To the environment, right?
Of course, to the environment. Yep. Good. 25. Which of the following is true about the pH of the water after the reaction is complete? Well, you are going to be getting a base and the products. It has to be basic. The pH has to be more than 7. Okay. So here, where is the big jump happening between which row and which row?
Second and third.
Second and third, right? Because from here to here, it's like a doubling. But then it's like times 4 almost. Yeah. And then times maybe 1.5 or something. So between second and third is the big jump. That means your element has to have 2 valence electrons. Now, the charge of the SO4 is a negative 2. That means your element must have exactly plus 2. They will cancel out. You get X SO4. Okay. Which of the following questions about the components on a mixture could be investigated with the paper chromatography? This is about separating the components of the mixture based on their polarity. Some will be traveling faster with the solvent and some slower, depending on their attraction for the solvent, on the polarity of the solvent, on their own polarity as well. So it's going to be choice C. Okay.
So what about for D? I chose it was like, what do we use for different speeds?
That has
gases.
Different speeds?
Yeah,
Yeah, maybe gases.
Yeah.
I've never seen a test for gas speed. Yeah.
Is paper chromatography always about polarity?
Always. There's nothing else that you can prove with it.
Myself, there was one about gas, I think. What was it? I forgot it.
Gas chromatography?
No, it wasn't chromatography. It was another experiment. I don't remember the name.
The column chromatography.
Yeah, is the column one?
Column is the same as this one, just upside down.
I don't
With a
remember.
syringe.
There's the stationary phase and
Yeah, even in paper chromatography, there's stationary phase and mobile phase.
the stationary phase is
Is the what?
the initial one.
The one that it's actually the paper. It's the paper, and the one that moves is the liquid. No. So here we're looking for a Bronsted-Lowry conjugate acid base pair, and so you're looking for something with an H and then something without the H. So for example, B would be perfect because you have an acid And if you lost that, it becomes a conjugate base. So yeah. And of course, D is going to be wrong because ammonia is a base, not an acid. So it's not going to be choice D. Okay. 29. Okay, so we are looking at taking ice and water and putting them together and expecting the ice to basically melt. Okay. So which one is the hotter object here? The water, right?
Yeah.
So we're going to do negative Q on the water is equal to Q of the ice. You should always put negative on the Q of the hotter object. Now, the water is not going to change phase, the ice will. So for the water is going to be negative MC delta T. For the ice, it's going to be the phase change, which means the mass of the ice times the heat of the fusion of 330. Now, the mass of the ice, we don't know what that is. It's going to be unknown. But the mass of the water, we know what that is. It's 100. So we're going to say negative 100. C is what? Specific heat capacity, which is 4.18. So look, actually, sorry, 4.2. Delta T is going to be T final minus T initial, which is 33. Mass times 330.
بس significant figures مالتك يمكن غلط بال FRQs.
Probably not, but we'll talk about it. Okay.
42.
42. Easy.
Easy.
So, here we have a weak acid and a strong base. So, what is this weak acid? Okay. Look, if you have a weak acid with a strong base, you can have something called the half equivalence point. And the half equivalence point happens at half the volume of the equivalence point. Whether the equivalence point takes place at 20 ml, it's going to happen at 10 ml.
10 to the power of negative 5.
Linked it to the y-axis. The pH is how much? 5. That means the pK is also equal to 5. So K is equal to 10 to the power of negative pKa, which is that. So the answer is going to be
C.
C. Okay. A solid is tested in a lab to determine its properties, which are following provides the best evidence to support hypothesis that the solid is a metal as opposed to a non-metal. Okay. Malleable is only given to metals, so it has to be choice B. Good. 32. 49% by carbon, carbon ion by mass. Okay, so we should just find out the mass percent of carbon and hope it's in the beginning.
It was A.
So how many carbons do we have in here?
3.
3
36.
times 12 divided by 74 times 100, and you get 49%.
48 point something, which is 49.
Very good. So we got lucky, it was A.
حتى اريا موجود.
Okay. You want to mix things together to get a buffer solution between the pH of 7 and 8. The best way to do this is just to go and find the negative log of these guys until one of them is very close to 8. So which one is that going to be? What's negative log of this one? Is it very close to 8?
Yeah, maybe.
Mm-hmm. So it's going to be choice D. Okay?
تعرف ما ايش سويت؟
What'd you do?
شي يسمونه dissociation مالتهم. مو neutralizing. KA مالته قلنا يكون اقل، يعني هذا it has a higher pH. I got the right answer.
You got very lucky, and you spent a lot of time, I think. How much
لا
time?
والله. يمكن less than a minute.
It
Maybe.
took me 10 seconds.
Yeah, I'm saying less than يعني يمكن ثانية واحدة ايش ما ادري.
Less than a minute became 1 second. Wow.
ثانية واحدة مو أقل من دقيقة.
Can you show
I
me?
specify.
Can you show me your method again?
الكي مالته قد يكون أقل يعني هذا البي اتش مالته يكون أكثر.
So 34. Okay, if they mention bond enthalpy, we should do reactants minus products. First, draw the bonds.
Was that necessary?
To draw the bonds.
Yeah, like. Okay.
I know people who don't and they get it wrong. I know people who do.
من هم؟
Like some people don't draw them and they get it wrong. Like so, and some people don't draw them and they get it right. So it's about the person, yani. But you know, it's better to get it, to draw it. Okay, so CH4. How many do we have? 4 CH. F with F.
والله رقبتي أساسا من قبل.
Really?
والله جاي أنام أكثر.
So more sleep makes the neck better now.
والله مستر السور ما يبقى في.
Really? Oh yeah,
أي
true.
والله.
زين الكايروبراكتر بعد تروح لا عشان مساج ولا كايروبراكتر؟
Physiotherapy, bro. Physiotherapy.
فيزيوثيرابي هذا اللي يحبك.
No, not that guy.
Take off the ring.
That guy, I don't go to him anymore.
ليش أكثر؟
Well, I mean, they told me it's very dangerous, the physiotherapy guys. They're like, you might like break your spine or something by
Maybe
mistake.
kissy, I don't know. It's actually
Yeah, I mean, he takes the ring off. No, it's actually worse than physiotherapy. You take your entire shirt off.
Oh god.
Yeah, also you take your funny off. So I think I'll stay with the chiropractor.
Okay.
Just the ring off. Yeah, they're like, what's the encourage to take it off?
داني. Yeah.
Okay, so I took off my shirt. They're like, wait, how about the funny? I'm like, oh, okay. That too. خلاص يعني علني يعني.
شو كان أساسي؟
Yeah. Sometimes you need to experience other things in life.
Yeah, so I'll go with the ring guy. I mean, I was embarrassed then. Oh, I did 10 sessions.
Oh.
Yeah, 10. Okay, not for that, but yeah. Yeah, I did 10. I don't know how I did 10. And he's like, you should do like 20 more. I'm like, dude, come on, with 20 more. I'm
He
very
wants
like,
to see you more.
جاي تشوف فرق؟
yeah, I guess. Huh? Well, I saw a big difference. My back is much better. I mean, look, I still have pain I'm doing right now. Neck exercise at home, like a lot of it.
Swimming لو لا.
They said don't do it. Yeah, don't do it, they said. Okay. So 35. I love these graphs because they're always easy, right?
And most of the time first order.
Yeah, he's right. Look, if you have the ln to be a straight line going down, and you have the concentration to be curving line, it's going to be the first order. So, B. Good?
بس ترى البنية ما يكون عندها قومات الشبايش يطقطق الركبة ويجي هاي
No, there's nothing like this. It's all machines.
شنو هاي؟
لا, what's the point of going?
No, like, they put the machine, and the machine does like this.
هاي المشين احنا عندنا بالبيت هذا مثل اللي شيء.
No, no, like it's electricity.
Oh.
Yeah. You should try one time.
تمام يلا
راح نجي فدية إن شاء الله.
نروح كلنا سوا.
Yeah, it's free, right? It's $40 a session, so I don't know. You can do that every day.
والله كان بشهر رمضان كنت أروح لأن كنت متدمر حرفيا.
Look, I still have.
يمكن الآي بي address.
Oh yeah. You're like, how do you have 20 laptops in the same house? Okay, so 36. Okay. So look. So MnO2. Do we see it in the reaction?
No.
No. Why is that?
Well.
It's a catalyst.
Catalyst? Okay.
Now, so what's happened to the O2 over time? Is it increasing?
Yes.
It is increasing, but at a slowing rate, correct?
Yeah.
So,
I
and if
should
you
see.
want to, no, it's not increasing because look, from here, you do 42 minus 0 over 60 minus 0. Then here you do 64 minus 42 over the same denominator. So you're going to have the top part of the fraction decreasing. That means your rate is decreasing over time.
Oh.
So it's B. Okay?
Yeah.
37. A second experiment is done under identical conditions using a higher concentration of H2O2 in the presence of the same mass of MnO2. The volume of the gas collected during the first 60 seconds will most likely be. So they used a higher concentration of H2O2. So back then, we collected in 60 seconds 42 ml of O2. But now if you use a higher concentration of H2O2, you expect to collect more than 42 ml, correct?
See.
Because you have the same amount of the catalyst, right?
Yeah, but look, you just have more reactant, and more reactant means more product. The student observes that under the same conditions, the reaction occurs at a much slower rate when MnO2 is not used, because MnO2 was a catalyst, as we already indicated. So a catalyst will do what? Will lower the activation energy. Okay. So we should do stoichiometry here, right? So we should look at the balanced equation. We want how many moles of products were produced. Oh yeah, if it says consumed, do we use the ICE or the ICC?
والله لا ما استخدمت ولا واحد فيهم واخذت الرايت انسر.
Yep, the ICC as you said. So we're gonna copy the equation.
So is it only when it says completion? Use
If they say fully consumed, then it's your job, not an option.
ما يحتاج والله.
You know,
جاي تصعب الامور بس انت.
I'm actually making your life easier.
Can we use Stoichiometry or no?
Yeah, you do.
No, it's gonna be harder.
You said it and then you switched.
You can.
IMO.
دقيقة واحدة ما ياخذ. والله stoichiometric
I think I
Zero.
can see it's harder for me. I don't know.
Consumed is minus 2x, so it becomes a 0. So plus 2x plus x.
Just don't understand the 2x and x.
You don't understand 2x till now? Oh, look,
39.
just go back to 0.
بس ما ياخذ دقيقة واحدة عم شو بس القى.
Anyway, so basically, how much would the x be to make the whole thing into a 0? X would be 3 times 10 to the power of negative 3. And so you get here 6. Such an easy question with the ICC. Okay. And so it's going to be choice B. Told you.
كتابات وهذا. عرفت سؤال.
You just have to be more proficient at using it.
هسه دقيقة احنا بالام سي كيو احنا ما نحتاج نكتب شيء.
لا ما تحتاج بس notes.
Yeah, just
يعني
just
اكتبها هيك
just pray to God
مو
and
احسن نسوي ستايكيومتري؟
do you know why I disagree? Do you know why I disagree? Because they want the moles of the products, يعني both products. And you must do it twice.
And not 3 over 2.
كويس يعني.
Some people will not do that. They will just do it once and expect to get a 5. We don't want to break their heart. Okay, so look, let's look at hydrogen versus oxygen.
بعد 25 يوم.
Yeah. Is hydrogen ever a plus 2? No. How about the oxygen?
No.
It was how much here?
1.
That's the exception,
Negative
right?
one.
It's a negative 1,
One.
and here it became
Zero.
negative 2, and here it became 0. So negative 1 to 0 would be the answer. Good? Okay, physical states of Br2 and I2 at 298. So look, at 298 Kelvin, we have the Br2 is a liquid and the I2 is a solid. So which one has more IMFs?
The I2.
Always the closer state has more IMFs, which is the I2. Which makes sense, right? Because I2 has more electrons than Br2, and so it's going to have more LDFs. And we just compare LDFs for diatomic molecules.
A.
It's going to be A. Cool. Okay. We're changing the temperature from 200 Kelvin to 400 Kelvin, but the pressure is also doubling. Okay. So what is happening? So look, PV is equal to nRT. So if the temperature is doubling and the pressure is also doubling, then the volume has to stay constant. So when P is direct with T, that's as long as the V is constant. So the answer is choice C.
We'll go back up.
Mm-hmm.
Okay.
Okay. We're having PbNO3 2HCl, PbCl2 plus 2HNO3. The final mass of the precipitate is higher. So look, which one is the precipitate? The PbCl2. But the final mass of the precipitate is much higher than predicted. If this ever happens, is because you did not dry the precipitate enough. So it had some water when you calculated its mass, basically. So the answer is going to be?
A. Right.
Wait. No, not the sample of the original reactant, the product, the precipitate itself, basically.
Oh.
Okay? So yeah. Good. 44. So if your delta H is positive, we have an endothermic reaction. So delta H plus NaF would give you Na plus with F negative. You see, if it's endothermic, you put delta H on the left. But if it's exothermic, you put delta H on the right side. Now, if you were to increase temperature for the first reaction, we will go right. But for the second reaction, we're going to be going left. The question says, which of the following is going to have more solubility, which means more dissolution if you increase temperature? It has to be the NaF, correct? Because you're going to be going away from it. So it's choice A. Okay. Okay, that's a hard one. Lots of math. Okay.
45?
I remember this
Easy.
question.
Yeah.
I remember solving it.
It was hard, right?
No.
No?
No.
It was easy.
We're living differently.
طلعوا قد كده ما شاء الله.
Give me the fives and then that's all I want.
I remember when someone sent it to me. He was confused back then, yeah.
He also sent it to me.
He
I
also
ignored
sent
him
it
for
to
like 3 days.
you. Oh, wow. No.
I was wait-
We answered it together. That's
Me and
the
you?
difference. No, me and Ahmed Salman.
Not me.
And what was the K that I sent to you?
Hmm?
The K, the small K. I sent you a message about asking about.
Oh,
the
you did?
small K. No, you answered me, but you said you didn't know what it was.
What?
I didn't know what it was?
Yeah.
Oh yeah, that was just a new equation. Where'd you get that
شنو؟
from?
I don't know. I saw a question.
Please show us your question.
Let me see.
I don't remember. Where
No,
it
it's
was.
in the chat with me. Okay.
By the way, so have you ever seen a question like this?
Okay. So guys, look. We should find the Q
راح تنشر هاي الريكوردينج اليوم لو لا؟
right after, like on YouTube.
لا لا مو يوتيوب.
Okay.
درايف.
Got too excited. Like right after this thing.
هاي الكويشنز اللي راحوا مني.
Yeah, it's all posted. C is specific heat capacity, which is given to us as 4.2. Delta T is going to be, we were at 25, we became 35. That's going to be at 10, right? So how much is that going to be in the math? Let's see how much that is since you guys are resting. I do everything here. 8,000. You're still finding that? Just leave it, man. Okay, now delta H reaction is equal negative Q over N reaction. Now, what's N reaction? The mole of the limiting reactant divided by the coefficient. Which one is limiting, the AgNO3 or the NABR, or are they both limiting? They're both limiting, right? Because if you multiply the molarity by the volume for both of them, you get the same exact number. And they both have a coefficient of 1. So, N reaction here is just the mole of one of them. So negative 8,400 moles equal to molarity of one of them times the volume of one of them, which is 0.000.
A.
So it's going to be choice A. Very good. Okay.
هاي جايبة غلط ثاني.
Hmm?
هاي جايبة غلط هاي question.
So look, we have 120 grams of FeS2. We want the amount of the Fe. So we're going to do stoichiometry here. 120 gram of the FeS2 times. If I have 1 mole of the FeS2, that would be the molar mass of 120. In the balanced equation, we have 4 FeS2. In the balanced equation, we also have 2 Fe, right? 2 Fe. And then we want the mass of the Fe, so we're going to say 1 mole of the Fe, 55.4 I think, no. What's the molar mass of?
عادة 55.44.
55.85.
Okay.
ليش ما أعرف ليش مختار البي. والله مستر بلاي بيولوجي من كل شوي يصير أنا بعقلي مختار البي بس ما أعرف بالورقة كاتب أي.
It happens. Just
يمسك يروح لي شايف قد درجات كل
it happens, but just be careful. Okay, so
Does it sound like DeepSeek?
it's so cheap. It's so cheap. It also gets a
It's not
lot.
on your level. It's not on your level.
It gets a lot of things wrong. Doesn't create any images. Well, it does not.
مو بعد جديد.
Yeah.
It's Chinese.
يحب الأمريكان هو عايش.
Yeah, I like the American stuff, man.
هذا إيلون ماسك كان عنده جروكس ما أعرف شنو بس وقف بالعراق ما أعرف ليش.
Really? I think it's called Grok 2 or something.
والله جروكس كان يشغل اسمه ما أتذكر اسمه. والله كنت أستخدمه أنا وبدل شات جي بي تي بس ما أعرف وقف.
Chat is the best, honestly, so far that I've seen. Anyways, guys, Br2 and I2, do they have the same bond length? Of course not. Otherwise, why would they have the different bond association energy? My question to you is, which one is the longer bond?
I2.
It has more shells, right? So if it's longer, you have to shift it to the right. But look at the bond association energy is going to be less, right? That means you have to shift it up. So shift right and up for I2.
Deep.
It's shifted right, the valley,
Isn't the
and also up. It's about the valley.
But how much is it's a single bond, right?
Yeah.
Isn't it like a deeper valley would be another bond, like a single bond or a double bond, or am I wrong?
Single bonds versus single bonds do differ in the energy because of the length of the bond. Yeah, so like Br2, Br has how many shells? 4, right? So it's going to be shorter than I2, where I has 5 shells.
Yeah, but the valley, I mean.
What about it?
The valley, مو على أساس إذا يعني if it's a deeper one, it's gonna be a double bond or a triple bond.
Double or triple or a shorter single bond.
Oh.
Yeah. Good. Okay.
25 يوم طبعا.
So guys, look, delta G is equal to delta H minus T delta S. Now delta G here is negative, and delta H is also negative. But how about delta S? Do we have less or more entropy as we go from left to right?
Less.
Less. Delta S is negative. So negative is equal to negative minus
Negative.
negative. So negative is equal negative with positive. So ultimately, the delta S is not going to help us get a negative delta G. It's the delta H that's going to help us get a negative delta G.
هاي questions ما أعرف.
Which is
D?
no, it's only entropy. I mean only enthalpy. Sorry,
هاي اختارت C.
entropy is actually going to make us get positive delta G. So only enthalpy is making the reaction favorable.
إيه بس مستر temperature يكون كلش عالي.
Yeah, if temperature is high enough, you're going to have more entropy than enthalpy.
والG راح يكون شو يسمونه
Positive, which you don't want.
Yeah, it makes D wrong.
It's not always favorable.
But it's saying that enthalpy is always going to be negative.
I know, but how about delta S?
Oh.
Yeah,
Delta S is negative, yeah.
delta S is negative, but negative with negative, positive. So you're gonna have positive entropy. It's not gonna help you with delta G being negative. It's not gonna help you. Okay,
48 زينة بهاي الامتحان لو لا؟
very good.
والله.
Yeah, it's very good. Okay, 49. Ammonia is what? An ideal gas. Okay, so if it's an ideal, not ideal gas. How would I know? It has IMFs that are strong. It has a hydrogen bonding. So what do you expect? You expect deviation. Okay. So
بس deviation يعني ما يصير غاز لو شنو؟
it's still a gas, but it's gonna act not so ideal by showing IMFs, by showing attractions. So it will deviate and have attractions between its molecules.
والideal عنده high pressure or low?
Well, look,
High
if you apply high pressure or if you apply a low temperature, that's the reason for the deviation from the ideal behavior.
يعني مو high pressure.
This is external, by the way. This is external.
يعني الايديال يكون high
Yeah,
pressure?
ideal on the inside has more
Oh,
pressure.
Okay.
I'm saying externally though, if you put high pressure or you put low temperature, you're gonna deviate some things.
Okay.
Okay, so if you guys look here, the volume, when you made your pressure 4 times higher, did the volume become 4 times less? Not quite. Is it exactly 4 times less? No. That means it's not super ideal. Okay? So what's happening here? We have significant attractions in the case of the ammonia. It's never repulsion, it's always going to be attraction. Okay?
C and D are wrong. يبقى U B ولا إيه؟ Attraction.
Those attractions make it occupy less volume than expected, basically. Okay, let's see. Which of the following statements correctly identifies which compound has the higher boiling point, which one has the most IMFs? Always go with the hydrogen bond, right? So that's going to be this one or this one. Either a propylamine or a propanoic acid.
شنو شنو question?
Which one has the most boiling point?
Okay.
So it's not A and it's not B.
مستر حتى شو يسمونه يكون بس هاي. تمام.
We only have the acid mentioned here. So it's going to be either C or D. It's never about
Bonds.
the bond being double or single, always about the IMF. The student mixed samples of each of the 4 compounds with water. Only one of the 4 did not dissolve in the water. Based on the structures of the molecules and the strength and the types of their intermolecular forces, the compound that did not dissolve is most likely. So which one is not going to dissolve in the water is the most nonpolar one. Which one here is the most nonpolar? Only it has LDFs.
Yeah.
So it's not going to dissolve in water. Cool. Okay. Of the following, which identifies the aqueous solution of the compound that will have the highest pH, and explain why? Which means, which one is going to be the most basic, essentially? Of course, nitrogen reminds me of ammonia, so it's going to be propylamine.
I chose C because of the OH.
OH was never acidic or basic. Was it? If you have COOH, that's acidic. But OH alone is never a thing. Okay. So, why do you think, guys, there's a square here?
Our fingerprints.
Yes, because here you have more absorbance than normal, so we have gloves on. We don't have any gloves. So we have fingerprints on.
مستر كان يكون الوتر concentration كان يكون أقل أو أكثر.
The absorbance will decrease, not the concentration.
واحد من اللي فاركيوز أعتقد كان مال 2024 كانوا جايب لي فاركيو.
Yeah.
ما أعرف الشرح مالته نسيته. كان يقول more water is less concentration أو إيش شغلة.
We should look at that.
دقيقة.
There's a fingerprint here. That's why it's higher than normal. Cool. Okay. So here we must build the ice table, but the ice table requires you to build it with molarities. Do we have molarities here? No. We must first find them, right? So what's the molarity of the H2? Mole divided by the volume, which is 1. So 1 molar. And the molarity of the I2 is the same thing. Okay. Let's now build the ice table. So H2 plus I2, 2H. You know what's funny, guys?
What?
Whenever I say let's build the ice table, you guys don't complain at all. But if I say ICC, you guys start to give us other methods to avoid the ICC. I don't know why that
بس والله
is.
مسيء. أكو مرات ما يحتاج ال ICC table.
But if it's ice, you guys never complain.
بس هذا
No,
لا.
ICC is, you never need it. You have another method always.
حتى النبار قال مو مفيد ICC. بس الايس تيبل ما عندك اي حل ثاني الا تستخدمه.
You guys are trying to just tease me here. Okay, let's get the X. I spent time on that.
So the malformal charge equation. Hi Zen. Hi.
It's actually pretty good. I should post that on YouTube.
ليش ما تنزل انستغرام ريلز مرات يجي لك مشاهدات هوايه والله.
Do you think I have time?
اليوتيوب ياخذ وقت اكثر هذا
انت ما تنزل AI هذا واحد.
It doesn't make videos, I think. Actually, I'll ask it.
والله اكو ايش يسمونه ويب سايتات مال اي اي يسمونه.
I'm tired of paying. I'm already paying for Zoom, for chat.
ليش؟
Well, Zoom to have like uninterrupted, like, you know, time, because limit is like 45 minutes. With Zoom, it's like unlimited. And I'm already paying for Sheg. It's like a question thingy, but it's يعني
هذا
it's getting outdated now with chat around, but
هذا اللي
it's important.
ينزلون الكويشنز ويا
Yeah, like the same question from like 50 years ago somehow is there and solved. I'm paying for 3 things.
بس قد الشيك انا من مرات يطلع لي قبل.
Sheg is $10 a month. It was 20, but I got discount because I paid for a long time. Let's find the K. I'm not gonna pay for
Don't
more.
you have to pay more for your drive when it becomes bigger, or no?
Yeah, oh yeah, sorry. I'm also paying for Google $200 a year. Yeah, because I have a year because I have 2 terabytes. Is it 200 or 100? I think it's 200.
اكو سوالف يوزلس مسحهم
Useless.
من 1990 ل 2010.
That's not where the like sizes is because of the videos that I'm posting. That's why it's taking a while.
Balancing the equation we have at 8 points.
Yeah, so how about the equation was 8 points worth
بس هذا يشوفون جول مود ماتي جول مسح.
0.25. Okay, perfect. We got it. I stable, no one complains. I'm just saying. Okay, now,
يا مستر انت تكون ريالستيك. حسب احنا هنا كنا نقدر نسوي ستويكيومتري بس هنا ماكو اي حل الا تستخدم اي ستيبل.
rate is equal to K and O2 to the power of 2. The coefficient of the only reactant in the slow step becomes the power. So it's B.
اذا كان هو اكوليبريم كان يتغير السوالف مو؟
Well, they said slow step.
اي لا اعرف اذا اقولها مثل ايكويشن اول واحد كان فاست واكوليبريم ما
Oh, yeah, things will change. Good?
كان يكون مثل دي.
Nice. The most molecules means the most moles. So which one here has the most moles with that mass? So look, mole
سي
is equal to mass over molar mass. If you want to have the most moles, you must have the least mass. I mean, the least molar mass,
H2.
which is H2O, exactly.
Yeah.
It's 18. Very sick. Very sick.
Very sick.
Very sick. Okay, 57. You want the most positive E. So pick the most positive cathode and pick the most negative anode. Which is?
لا مو هيجي. استخدم equation من الانسر شو يسمونه من الام سي كيوز احسن.
Oh yeah, we don't have Ag and zinc, do we?
يا لا ما
No. Didn't work. So that's going to be the cathode always, right? It's the most positive
So it
one.
has to be A.
So cathode minus anode, which is this, and you get 0.94. But in here, they made the Ag the anode, they made the Sn the cathode.
Negative
So negative 0.14 minus Ag is the anode now. So negative 0.94. So it's not B. And here zinc is getting oxidized, so it's the anode.
مش ما يحتاج القط.
No need, right? Just
Yeah, A.
okay. Which of the following identifies the four species that are present in an aqueous solution of the weak acid from the highest to the lowest? Always the acid has to be the highest. Okay, always. And the conjugate base, the second one, has to be the lowest.
I trust C.
So the acid has to be first,
So D.
and the conjugate base, the second one, has to be the least. That's always the case, by the way. That's the acid, and that's the second conjugate base. Cool? Yeah. All right. 59. Do you guys do this one? You have to write the
Yeah.
dissociation equation. Oh. So this is x. This is 2x. So
3x.
yep. So, what?
No, 2x.
Big mistake.
2x.
Bigger mistake. KSP is equal to x.
4x.
2x squared. 4x cubed is equal to KSP.
أول سنة من كنت أسوي في كيمستري هذا مش أنت دبرك ما أعرف ليش.
والله طولت ساعة على يجي سؤال.
Till this day or
Last
before?
year- Last year was
لا
last year.
سهل هذا هسه بس بالكالكوليتر ولا اكتيفيشن قبل.
So it's going to be 2.0 times 10 to the power of negative 3. That's the x. And they're asking us for the PB, which is the x. So we're good. Good?
Yes.
60, largest dipole moment. Pick the two atoms that are farthest apart from each other in the periodic table, and also avoid the symmetrical geometries.
So avoid B and D.
So avoid D,
Even B.
avoid C.
ليش C?
It's trigonal planar. That's symmetrical. They just drew it for you in a confusing way, by the way.
يصير cancelling.
Yeah, they canceled because we always draw it like this, by the way. But they, linear avoid. I'm not gonna curse, but yeah. So it's A. This is linear.
I was between A and C. I chose A.
Tetrahedral, trigonal, planar. Avoid them all.
Yeah, China was non-polar.
And also square planar.
Tetrahedral, square planar, trigonal planar.
Yeah, and linear. As long as the atoms on the edge are the same, like you have both S's or you have all F's or you have all Cl's.
مثل التريبل بوند يكون 2 باي و1 سيجما لو شلون؟
Yeah, 2 pi 1 sigma.
هاي من السنة اللي راح سألك يوم قبل الامتحان